Let me know when we have start, and will there be any context setting introduction?
No, sir. We'll request you to start the session with setting down the context a little bit on the topic, and maybe then running the panel discussion.
Sure.
We had a brief meeting on the other day. I mean, I may suggest you may, since the audience will be large, you may like to quickly introduce the panelists, and then we can start.
What Ms. Archana said, we will start with the context setting, so the moderator's note, and then we will introduce the panels, and then panel members, they will come and speak. Yeah.
So we can start.
Okay, so let me just share my screen so that I'm ready for my presentations, and then I will start the talk. Okay, so hope you can see see my screen slide.
Yes, sir.
Okay, so good afternoon, all. Very honored to be here speaking with you on the Internet of Energy for the Global Reinvest Summit we have. As you know, this is very important for our country as we are moving towards more of renewable energy, and also would like to accelerate this and expedite this with collaboration from different stakeholders. And in this session today, we have the topic how Internet of Energy, how the world of AI and digitalization is going to be the enabler for surging ahead with our renewable energy goal, the strategy, and how we can build an ecosystem among different stakeholders with the technology, starting from the proof of value, proof of concept, deployment, and also collaborating to ensure that they are scalable, they are also sustainable for future. So I'm Akilur Rahman. I'm CTO for Hitachi ABB Power Grids India. So I've been in this field for more than 31 years, working in the power systems, power products. So I have masters. I'm introducing myself. So I have master's degree, from IIT Kharagpur in power systems, and I have worked with ABB for more than 31 years. And in this, I had gone through different phases, including starting from engineering, product development, R&D, technology management. I have seen how the technologies in this area, they can be conceptualized, they can be developed as prototype and deployed, and also get the experience to also continuously innovate on these. So I will try to share my experience here, and also I have very eminent team of panels, experts from different areas, from academics, from the industry, from the research institute, from the incubation area. They will also share their views. I will also introduce them in the course today. So feel free also to share your questions. We'll also be having some questions to the panel members, and we'll try to address them, how we can collaborate with each other, including you, the audience. You might be from different stakeholder entities. So my talk would be very high level, just to set the context, and I would invite our panelists to share their views. Hope my slide is changing. I'm slide number 2. Just somebody can say.
Yes, sir.
Okay. So before we get into the details, the discussion. So I'd like to set this context that how renewable energy value chain is evolving with trends and technologies. And if you see, very important when we talk about the energy, it gets produced, generated in the utilities, and also they are transmitted. They are consumed by industry, by the infrastructure and transport, and also society as consumer. And looking at that, what are the big trends? So if you see shift to renewables, this is the subject for us, which is a very big trend here. And also the other one is digital grid, that is the energy internet. So power system as a network and having all these different mathematical algorithms and also a lot of sophisticated, even expert system, AI has been there for several decades in power systems. But today we are talking about also connecting all the power assets and systems and devices and operations, not only through electricity, the transmission of electricity, but also the data. So that's how we call it digital grid, internet, energy internet. And you look at industry, so industry 4.0, the fourth industrial revolution, that's the topic what you already know. This is another revolution is happening. And on the industry side, we have collaborative, flexible manufacturing, real-time optimization. These are the big trends. And on the infrastructure side, smart cities we are talking about, and also in India, we have all these initiatives and electric mobility and mobility as a service. So if you look at the value chain, when we produce energy, even the renewable energy, how it is flowing through all these different sectors and how it can impact all these different big trends, including Industry 4.0 and industry, smart cities, e-mobility. And the common here is, of course, common to the energy, common also to the renewable energies, the core technologies we have in the power systems in the energy domain, and automation and digitalization. So this sets the context that, okay, with this, probably we can also leverage the digital technologies much more here and bring the renewable energy ecospace to the next level. I'll just talk about a little bit how the energy system has been. It's a little bit of technical, but I would just give you very quickly that the automation of energy system, power system has been there for several decades. They have been connected. We call it intranet of things. Rather, they are connected with a lot of intelligent devices, primary equipment. You have SCADA, you have network control. So they have been there for several decades. And what we are doing now with the Internet of Things is that we are putting some sensors, additional sensors. Of course, all these devices, they already have sensors, but we are also now putting additional sensors so that the sensors can take the data to the cloud. The cloud can be a private cloud or a public cloud. Why we are doing it, that we are making this data available to the larger set of experts who are sitting within the company, within the organization, or maybe different plants of the same organization, or the different service providers, academics, policymakers, so they can have this data available and they can analyze it. They can relate this data with the weather. They can relate it to the market, relate it to the user requirements, demand. So that's how they can come up with either finding some problem statements to solve, or they can also come up with some improvement areas, opportunities for improvements. So that is why we are using this IoT and digital technologies. And digital technologies, they are like virtual augmented reality. We have machine learning, data analytics, artificial intelligence, software defined machines, and blockchain. We also have 5G coming, which can be used effectively in this. Cloud computing we are doing so that we can scale it up. And also the inexpensive computing, which is basically providing us opportunity to collect the data with the sensors, gateway, and provide the data so that we can analyze and make the system more efficient. So here in renewable energy, because it is again starting from the generation going towards even to the prosumers, we call it. Prosumers basically are the earlier consumers who can still be also producer of the energy. Let's say somebody having rooftop, he is producing energy, and when he's not there, not using the energy, he can also supply to the grid. So that's why we call it prosumers. So the entire ecosystem can be monitored, can be analyzed, and also can be optimized. And when we talk about this digitalization and also the Internet of Energy, we always focus on some performance parameters to improve. They can be productivity, it can be quality of the power, and also the quality of production. Let's say if you are using it for industrial environment. We can also use it for safety environment. This application we can use and also ensure that it is cyber secure. We can also use it for monitoring the asset performance with asset performance index, which can say that this asset is good or bad, or it needs some service, and then in real time. So that makes the entire system more reliable, more available, and also predictable. And with the renewable energy getting penetrated in the system, I think this is a very important element, and also technology which can really make it happen more efficiently, and we can also scale it up. So coming to this ecosystem, if you see on a very high level, you see that starting from, you have the production of energy in the conventional way, and also the renewable. And you have consumers, different type of consumers, you have different type of loads. If you see, all these things can be connected, can be integrated in an environment, IoT environment, where you have data coming from your conventional plants, coming from your renewable solar plant, also connecting also to the EV charger, electric vehicle charging system, and also connecting to your homes, connecting to AMI, the meters, and also the industry's entire system is connected. In addition to having the automation system, they are also connected with this IoT system, by which, again, as I said, we can get the data, analyze the data in real time, and discover problems, discover opportunities to solve, and make it more efficient and also scalable. So this is the context. I think we have eminent panel members who have been working in different areas, and they would also like to share their views, and then we can have a discussion. And one thing is very important here to know that as a country, we have now one grid, integrated grid. We are also sort of supplying power to the neighboring countries, and we have in spite of having a diverse source of energy and also different type of loads, large geographical area, we are, I think, one of the best in maintaining our grid. And also, as the renewable energy is getting integrated, we are also managing it well, but we can do much more with collaborative effort from all of us, from all different stakeholders. So with this, I will stop here, and would like to introduce to our first panelist, Dr. Madan Mohan Tripathi. So he's a professor in Delhi Technological University, and so he has been in the position of Director, Internal Quality Assurance Cell, and Coordinator, Intellectual Property Rights Cell. Has more than 26 years of experience with the organization, and so he has been working in the skill development, ICT-based skill testing and certification framework. So over to you, Dr. Madan, to share your views on this.
Thank you, Dr. Rahman. A very good afternoon to everyone and my fellow panelists. I hope my voice is clear.
Yes.
Okay. So I thank the organizers also for providing me the opportunity to speak in one of the most relevant sessions, Internet of Energy, World of AI and Digitization. See, if we start drawing parallel between the power system and the IT systems, we can draw many parallels. In power system, there is a highly interconnected grid of transmission and distribution wires with generators supplying the power to the consumers via the grid. In IT system also we see that the service providers are providing services to clients or the users with a very highly interconnected network. The only difference is that in the IT system they deal with very low, extremely low voltage and low power, but in power system we deal with high voltage and high power. So handling a power system becomes more challenge. If I draw another parallel with the IT cloud system, which provides different services to clients anywhere, anytime in a scalable manner, we can again see that even in the electricity sector, there is a cloud is being formed in the process of forming energy cloud, and it will become a reality due to increasing demand response and the consumer becoming the priority. Utilities have to provide electricity of desired quality, amount, at the place and time decided by the consumer in future. And so this will demand optimization of assets to provide the cheapest power. And the electricity cloud may result in the efficiency and profit to the utilities and cheap power with quality to the customer also. But to meet such a variable demand and ever changing demand, it will become very much necessary to have high penetration of the renewable energy in the grid in a very distributed fashion. We are seeing also that grid is now getting connected with a lot of solar PV, wind, and electrical vehicles connected to grid, and they're also increasing at a faster rate. In the first quarter of 2020, the share of renewable energy generation was 28% globally, and in India it was 26%. And it is expected that by 2040 it will be around 50%. So this is creating an unique opportunity for consumers to interact directly in balancing the demand and supply in real time using the digital technology. The local balancing will mitigate the congestion in the grid, and also it will provide ancillary services to the distribution operators. But to manage such a complex and dynamic situation, infusion of IT into the power system or the energy sector is becoming a necessity. We need to have a lot of IoT based health monitoring systems of components to reduce the unplanned outages. Every equipment will have IoT as informed by Mr. Rahman, and these IoTs will be updating a lot of data to the cloud on very regular intervals. So this may create a huge unstructured data coming at a very high speed. So analyzing such data to get a meaningful information will certainly need the technologies like artificial intelligence, big data, etc. Artificial intelligence will be used for accurate renewable energy forecast, demand and price forecast, and formulating the optimized bids for trading electricity market, which may be on the scale of 15 minutes also in case of renewables. Here in our university, our group work a lot in developing of algorithm based on the deep learning to forecast the renewable energy generation and demand and prices. The AI can also be used to develop automatic trading and hedging recommendation systems. AI may enable better decision making, planning, and operation of energy grid in future. With all these advantages of artificial intelligence and the digitization to the grid, there are certain disadvantages will also follow. And I want to mainly focus today's talk on that. And that will be the lot of cyber attacks on the grid. Recently, it has been reported that in the energy industry is getting 32% of the total cyber attack in the world, which is highest in any sector. There are certain examples. In March 2019, the exploitation of a vulnerability within a firewall of a wind plant operator resulted in a denial of service condition, disrupting all communications between a control center and a renewable energy generation site. Also in December 2015, an attack in Ukraine left 0.23 million people powerless, and a year later, there was an outage of 200 megawatt due to cyber attack. As per the Symantec Threat Report 2017, India has been ranked fifth most vulnerable country in terms of cyber security breaches after USA, UK, Canada, and Australia. So it's time for government, regulators, utilities, and other stakeholders to push for cyber security measures in renewable sector. As electricity system operates in real time and cannot simply install patches or updates or shut down and reboot in case of digital failures or breaches as done in IT systems. Hence, any cyber attack may become very disruptive, and that may result in huge financial loss to the power sector. So there can be many types of cyber attacks. For example, an attack on the AGC systems or smart controllers of solar PV panel or wind plant, attack on field devices, communication network on the SCADA systems, some false data injection attack on the fax devices and equipment, or maybe social engineering attacks. So it is important to protect the power system with a proper cyber security framework to identify, protect, detect, respond, and recover from cyber attack to ensure the business continuity in the power sector. All stakeholders must establish an effective incident response capability. The periodic risk and security assessment must be performed and emergency response plans should be in place. Standards, which is not there, should be developed for renewable energy components, communication protocols, and management of cybersecurity risk. IT-based virtualized test bed may be useful to analyze, evaluate, and demonstrate cybersecurity resilience, and to develop preventive and protective measures, analytical tools, and security strategies. The blockchain technology can be a very much potential cybersecurity solution if used to validate whether a device is running up-to-date firmware or has not been tampered with. It can also address the challenges of identity and access management as well as ownership and integrity, as it provides identity with a set of attributes that can be stored on the distributed ledger in a fully auditable manner. Other techniques like swarm intelligence can also be used for anomaly detection in the compromised smart meters in the advanced metering infrastructures. There are many other uses in security of artificial intelligence, like smart contracts, which could add unique value in the timely response to emerging cyber threats, like an emergency response to a naturally occurring weather event or a cyber physical hybrid attack, which may make some functions of the power grid self-healing and resilient. The intrusion detection system assisted by machine learning could be an effective method to detect intrusions and attacks. So such a system, which is combined with the blockchain also, could provide well-established timeline of events for evidence analysis in case of a security incident, reducing the overhead of the forensic investigations. AI and digitization plays a major role not only in managing a complex renewable energy system, but it is also helping in protecting the renewable energy system against cyber attack by providing advanced tool and techniques. So AI and digitization is basically enabling today's grid and especially the renewable energy in a great way. And I hope that we are going to see some more and, important points by the next speakers in the panel. And then we'll also discuss these areas in future. Thank you.
Thank you, Dr. Tripathi. It was very, really enlightening sort of topic you touch upon, including the cybersecurity and how the technologies like blockchain and the artificial intelligence can be used in this area. Now I invite Dr. Abhishek Kumar. So Abhishek Kumar is head of Solar Systems Technology, Solar Energy Research Institute in Singapore. He heads the Solar Systems Technology Group at SERIS, the Singapore National Institute for Applied Solar Energy Research. And he has more than 11 years of experience and has gained widespread experience in the whole value chain of photovoltaics, starting from high volume advanced manufacturing processes in microelectronics, development of high efficiency industrial wafer solar cells. And so he has a degree from National Technology, National University of Singapore. So I invite now Dr. Abhishek Kumar to share his views.
Thank you very much. Thank you very much, Mr. Rama. Just give me a minute to share my slides, and then we can go through it. Are you able to see it?
Yes.
Okay, great. Thank you very much for this opportunity, and a very nice good afternoon to all the participants as well as my fellow panelists. I will quickly take you through what we do in SERIS, and followed by giving you a few examples. How do we see in terms of AI and digitalization? To start with, basically, SERIS is a national level research institute in Singapore. We are founded in NUS in 2008. and then we are funded by the NRFN Economic Development Board of Singapore. Our main focus is towards the applied solar energy research, towards the cell, PV panels, and PV systems. We are the national lab. We don't only work on kind of research items. We also work with industry and government agencies in terms of identifying what are the roadblocks to deploy solar in Singapore, and then working with them. In that sense, this is our main research vision in terms of developing a commercial solar technology suited for urban environment. This is what is our focus more in sense, because we are located in Singapore, and that's where is our main focus. Main R&D area where we focus is the cell technology, which is upstream cell development of high efficiency cell technologies, and what is coming next in the solar industry. In terms of PV module as well, we do something similar. We try to develop new panel technologies, which is coming up next. And downstream in terms of solar system, this is where basically our main job is to develop new high efficiency PV systems in terms of test bedding those activities, and then kind of de-risking it for wider scale deployment. For example, building integrated PV, floating solar, PV grid integration, and solar potential energy metrology, right? Now, this is the whole value chain where we serve in terms of solar energy. We, as I said, in terms of cell, panels, and systems. Now, in terms of focusing more on the downstream, as I said, we basically focus a bit more on the on-grid PV system technologies, try to optimize the performance, and in terms of PV potential and how the deployment of PV will affect the grid. Because in the sense that some of you might have heard recently in Singapore, the government has announced 2 gigawatt solar deployment in Singapore. And then this will, by 2030, this will bring in quite a large amount of variability in Singapore. Now, in that sense, how do we look the industry in terms of AI and digitalization in the solar industry? Now, I'm going to, because we are a research institute and we keep an eye from upstream cell to downstream PV system. So now, how do we see the PV upstream? In terms of upstream, as Mr. Rahman was saying, that definitely the manufacturing industry is seeing a more adoption of AI and digitalization in the solar industry. Now, talking in terms of upstream cell and panel technology, as we are moving more and more towards the high efficiency cell technology, as some of you might know, that the previous technology generation was BSF solar cell, and now we are going towards the high efficiency. So these type of high efficiency cell technologies will require more and more implementation of the AI and digitalization in the manufacturing process, and which will come up in the solar upstream manufacturing. In addition to that, we are also seeing faster material and device development using AI technique has been coming up. In past cases, usually a device from lab to fab would used to take 10 years or more than that. But recently, because of the development of AI techniques, the devices can be optimized much faster, and the processes can be optimized much faster. And then the process of moving from lab to fab can be moved faster. For example, you can see a graph here. This is an ITR PV, industry technology roadmap of PV, and basically you can see that they have kind of predicted the automation and use of machine learning things in the smart fab, which is coming up in the solar industry. Currently, it is quite low, around 20 to 30%. Usually, most of the factories in China, they are not using it, but some of the factories in other countries, which are developed countries, are using it. But we foresee that it will going to grow fast, and you can see the share will be going to 80% and 90% in 10 years down the line. Now we are talking about downstream PV system. Now here the main challenge. Now I'm talking about from a Singapore perspective of a distributed PV system in urban environment. Now there are quite a lot of challenges in terms of distributed PV system. You can see this is the type of PV deployment happening in rooftop in Singapore. This is very complex, very narrow rooftop and high-rising building, and then very distributed PV. And now you can imagine gigawatt scale of this PV deployed in a distributed fashion. Operation and maintenance of PV systems becomes a huge challenge. Usually people use about preventive maintenance, people talk about corrective or reactive maintenance, but the future will be more towards the predictive maintenance aspect, where a system can be predicted that how it will perform in future. Now, moving forward, what are we doing in that sense in terms of research and development aspect? We have been working in terms of developing smart operation and maintenance strategy. This is basically, we have our own monitoring system. We collect a lot of data from Singapore, other places as well. We are trying to work on creating some artificial faults and trying to figure out if that fault can be detected from data which we are collecting. And in future, these type of smart data fault detection mechanism will be used to predict the power generation in future and give an early warning to the operation and maintenance team that there's going to be a fault. In addition to that, obviously, solar resource forecasting is an important issue, which is coming up in India as well and in Singapore as well. We are working on a solar forecasting project as well, where basically there is a different level of forecasting model. Eventually, the forecasting models are developed on simulation and satellite data, but these models can be refined based on using the machine learning techniques which will be used there. And then as the forecasting becomes longer and longer, this will be a very important factor which we foresee. Now, in terms of variability management of PV, again, in Singapore, our main focus has been to map the PV rooftop, PV surfaces, develop an irradiance model based on that, based on time series, based on power generation, based on forecasting, combine it with the PV models of storage, energy, as well as the control model, and trying to figure out what are the issues generated by this PV system, its variability on the grid, and how it can be managed well in terms of variability management of PV. So this is what we as a research institute see what is coming up in the future, and this is what we are doing at the moment in series to act towards more from a urban solar deployment point of view. Thank you very much.
Okay, thank you very much, Dr. Kumar. It was good to hear how you are sort of reducing the development life cycle of the solar, the value chain, starting from the cell to panels to systems, and also how AI can be used for predicting something which can be improved or which can be also solved. I think very good example to learn from you. I think this is the area where we need to all collaborate and see how we can work together to really make it more scalable, faster in deployment of renewable energy. So our next panelist is Dr. Venkat Venkataraman. So he is the Executive Vice President of Engineering, and he is the CTO for Bloom Energy. Just to know that he is joining this call from US. It's middle of the night. Thank you, Dr. Venkat, for, we also had the pre-call during the middle of the night for you. So thank you so much. Dr. Venkat had almost more than 17 years of experience with Bloom Energy. Many of you might have heard about it. And then they have a breakthrough technology in solid oxide fuel cell. It's called SOFC technology. And Dr. Venkat has been working in the engineering and also innovating around the world in the areas of fuel cell stack technology and also commercialization of the SOFC technology. And so how they have used the core technologies of developing this, energy resource at the same time applying all these new technologies. So would be glad to hear from Dr. Venkat. Over to you.
Thank you, Mr. Rahman. Can you hear me okay?
Yes, we can hear.
So I think it's a good thing I'm hearing that as panelists. We have a pretty common theme, which is great to know. I'm going to be focusing more on two things. One is obviously the microgrid, so the decentralization of grid itself. As you might know, grid is becoming unstable across the world, and it certainly requires a treatment, and we do need a reliable microgrids. Secondly, I'm going to start thinking about on how do you actually use the renewables is not necessarily specific to Bloom itself. How do you actually kind of incorporate all the renewable sources in power generation? And then bring in the concept of artificial intelligence and also data management in that context. On the left-hand side, what we see is the microgrid that we envision. First and foremost, there are two different segments on that. One is the power generation itself and the integration of the power generation. So we produce on-site power using fuel cells, the solid oxide fuel cells. We can take the natural gas or biogas or hydrogen to produce power. On the same token, the DERs or the distributed energy resources need not be restricted to fuel cells. You will have solar, wind, or any other source that can exist on premise to decentralize the grid. Now, so they all have to speak a common language. That's where I think quite a bit of work is done in the past, and more work is being done in the future. Also, primarily, we are all inverter-based technology, and then ABB, as you might know, have been an expert in that, both in the grid parallel mode as well as the islanded mode. So we learned a lot from them. And the downstream of it is actually all the customers that we need to take care of. So there is an integration to the business management system and other regulations that you need to comply with. How do you bring the renewable part of it? From Bloom perspective, we run on fossil fuel, right? This is the methane or the natural gas. And we are developing the technology to do the carbon capture. And also, as we move forward into the future, we are going into renewable hydrogen, which is the hydrogen produced by renewable sources. And also, we are big in on-site or directed renewable biogas as a feedstock. Now, in going into more on the AA part of it, I think we kind of parse it in three different ways. On the left-hand side, you can see the servers. These are the Bloom servers. To this date, we have deployed close to 100 plus microgrids. First and foremost, you have to have a smart HMI, and obviously you have to collect the data. Then it goes through the OLTP, the standard processes that is used in industries. Then you collect the data, then the collection of the data now has to go through the processing, both for forecasting as well as failure analysis, in addition to creating the reports. It's a common theme used from all the industries. What we specifically have to focus on is the aggregation of the data. And obviously, you have to use the cloud for scale up. And in addition to that, the machine learning and the AI are used because you live in partly deterministic world and partly non-deterministic world. AI is an important tool, particularly if you're going to be integrating many resources, energy resources, and also the transmission of power, whether you are doing in an islanded mode or a grid parallel, or whether you're in front of the meter or behind the meter, all the concepts will be likely to be the same. And furthermore, the most important, we talked about cybersecurity. So the data security is an extremely important entity we all have to take care of. So if you think about the data flow view, we talked about it on the left-hand side, what you have, the sensors, how do you actually collect the data? Then there is a thing, we have to have innovation in terms of transmitting the data. And third one, we have to think about the security of the data. And finally, going into monitoring as well as analysis of the data. The theme is common for all of us. I think hopefully we can collaborate in a way that we can leverage different pieces of it. For Bloom, I think we have been pretty lucky in the way that we have been the energy source itself. In addition to that, we have to develop all these technologies. Many of them are homegrown, some of them are borrowed from others in terms of reliable architecture, data architecture that allows automation, that allows the insertion of artificial intelligence, that allows us the machine learning, all these processes. So I'm looking forward to the panel discussion because we all have a common theme. And as I said, we are pretty unique in that, in our respect, even in the microgrid. As you might know, ABB may appreciate it well that we need a constant source that's us, and then we integrate with the intermittent sources like solar, PV, or any other source that exists on site. I'll stop here. I'm looking forward to the discussion. Thank you.
Okay, thank you, Dr. Venkat. So this is really a good example of how source of energy, which is with the deep research and also the technology development, how you are packaging it in terms of microgrid and also integrating in the system for the consumers is very important. Although you may have a lot of technology sometimes, but we are not able to really make it available for the last mile consumers. I think this is a good example of how Bloom Energy is doing that, while in the core of this technology of generating energy, but at the same time how it can be delivered to the last mile to the consumer. Excellent example also how you are using the data flow and also trying to sort of analyze the deterministic and non-deterministic kind of scenarios, which is very important in power because there are things which are in millisecond. They need to be analyzed, managed, optimized, and there are also things where we need to probably do it in minutes and hours. So combining both. So very good example. Thank you so much, Dr. Venkat. We have while doing all these things, I think we need all the funding, the economics of it. So now I invite Mr. Kunal Upadhyay. Mr. Upadhyay is the CEO, Chief Executive for Investments in Clean Tech. It's a center for innovation and incubation and entrepreneurship in IIM Ahmedabad. So Mr. Upadhyay has been the co-founder of Bharat Fund and CI's company at IIM Ahmedabad, and he has been working with MNRE, BP, IFC, and others, and also is the advisor to Asian Development Bank. We are eager to listen to you, Mr. Upadhyay, how you are sort of contributing to the commercialization of this technology and also incubating and funding this. Over to Mr. Upadhyay.
Thank you so much, Mr. Rahman. It's a pleasure to be a part of this August gathering and really privileged to have heard the thoughts of the speakers prior to me. I think they've covered the nitty-gritties of what it'll take for Internet of Energy to pan out. I mean, of course, as someone who works very closely with game-changing entrepreneurs, it's always exciting to learn about what new R&D aspects are being developed in academia or in startups or large companies like Bloom Energy. What I do is I work with entrepreneurs, and I mean, we've got one of these entrepreneurs sitting here in the panel with us, Vishal. We work with young and not so young entrepreneurs as well, help them provide access to various things that are required for conversion of an idea into an enterprise, help them scale up. Very often it means they need risk capital, very often it means they need a good amount of hand holding, but most often they need a shoulder to cry on. And we are there to help out these entrepreneurs navigate the nitty-gritties or navigate the various challenges of being an entrepreneur. Of course, in today's conversation, I want to keep the conversation focused on the topic, which is around Internet of Energy. And given the fact that I work with early stage entrepreneurs who are always envisioning the future, in my mind, I'll zoom out a little bit, think about what the future of energy could look like. I'm hoping there'll be some entrepreneurs sitting in this audience who will have some ideas getting triggered in the process. Of course, the energy sector today is where possibly the telecom sector was maybe 20 odd years back, which was archaic, costly, hard to install, repair. And of course, we've seen significant disruption that has happened in the last few years thanks to the wireless telecom revolution. And it's really a great sign of the progress that the technology has made that Venkat, who's sitting in the US, is able to chat with this group as seamlessly as anyone sitting in India. And I think the future of energy is going to be very similar. It's a matter of time before, while I am visiting Delhi, my electric car, which will be parked in Bangalore, will be getting automatically charged by using surplus energy that is being produced by a friend who's sitting in Chennai. Maybe it will go a step even further, and the car will figure out the most cost optimal way of sourcing energy. And for a 30-minute charge, it will possibly be sourcing energy from 10 different places across the country. Maybe the solar plant that we are talking about will know a week ahead of time what exactly would be the irradiation, not just in the city, but right above the plant. It will be able to send a signal to a drone sitting nearby that, hey, I need to be cleaned. The drone will show up automatically, clean up the panel, go away, everything, the entire transaction happening in an automated manner. So in my mind, this is what the future of energy ought to look like, maybe in another 5 to 10 years down the line. And of course, nothing will beat the fact if there could be almost a distributed energy stack getting created for the country, just like we've got the India stack having gotten created, which has disrupted the entire financial technologies world, which has disrupted, I mean, whether it's Aadhaar, whether it is UPI, if there could be a similar disruption coming in this space, nothing beats that. Of course, a lot of technology trends have to come together for this to happen. Internet of Things is already there. Today, we see a lot of connected devices. It is allowing people to create digital twins of physical world. We are seeing significant amount of devices today, I mean, across the world, whether it is refrigerators or lights or fans, which are now connected. The communication layer will allow soon your fridge to be talking to your solar rooftop plant. Artificial intelligence is going to play a very active role. And I mean, we did hear about other technologies, whether it is blockchain, cybersecurity, micropayments, everything is going to all come together and make this revolution happen. We see a lot of action happening, and maybe just touching upon some of the things that are happening out there. The Internet of Things, Internet of Energy revolution has really started in the Indian context from the demand side. That is, the entrepreneurs are creating solutions for the customers, where startups are actually actively working towards digitizing factories, retail spaces. They're adding a communication layer to existing devices or creating new smart devices. Today, there are sensors which are embedded pretty much across a factory, across a retail space. There are newer low-cost meters getting created and smart meters being created, communication layer being put on top of meters. So a lot of interesting action that is happening on the demand side. I mean, of course, there are globally companies which are able to just put in 1 meter in a factory or a household and disaggregate the data, figure out what the most energy guzzling appliances are, have the appliances talk to each other. So a lot of that action is already happening, and quite a few startups that we have ourselves supported in that space. So that's an area of big disruption. On the generation side, of course, we've got startups like RE Connect, and Vishal is going to talk more about it, who can forecast the future, what the electricity generation from a wind turbine is going to look like. There are others which can track the performance of a solar module or a wind turbine basis big data and collect data over a long period of time and predict not just future generation, but also predict kind of when the maintenance is going to be required. So those kind of opportunities will also open up. And finally, there's a lot of big opportunities that exist in the transmission and distribution side. I mean, unfortunately, in the Indian context, we are not seeing too many startups disrupting the space, but we are really looking forward that a combination of IoT, AI, big data, and use of smart payments and blockchain will really create a fantastic future for how we consume energy and produce energy going forward. Back to you, Dr. Rahman.
Okay, thank you, Mr. Upadhyay. You brought the consumer or prosumer aspects, how even to start with a car, how it will get charged and what kind of, where from it is getting the energy. diverse source of energy across the grid and value chain, and also at the same time how the charging will happen and what is the experience. I think it's very important to look at the user experience, the consumer, the prosumer experience, which you brought, and also how the different technologies like blockchain and also the sensors, they can be used to realize this application. And also, I think this is definitely inspiration for people who are looking for, working in the startup area. So coming from the startup world, we here have something which is scale up. Scale up company. I mean, this is good to know that, okay, we are now into the next step of scale up. So here we have Mr. Vishal Pandya. He's a co-founder of RE Connect Energy. And so it's India's largest energy analytics scale up. So that means you have passed through the startup phase and now you are scaling up. And this is what the need for the country now, when we have a very aggressive target. I'm sure we can make it with a collaboration among companies like you and also different stakeholders. So Mr. Pandya, he has been in the business development, utility scale project management, team building, and also as a founder, he has started the company with startup and now is scaling up, and also has good knowledge about restructured power markets and energy trading. So over to Mr. Pandya to hear from you.
Yeah, hi. Thank you, Mr. Rahman, and good afternoon, ladies and gentlemen. Let me start sharing my screen first. Yeah. Is it visible now?
Yes.
Yeah, hi. So good afternoon, everyone. And I think the time could not have been right, while we're not talking about internet and digitalization and AI. I think the pandemic is only going to push these areas further deeper into every aspect of life. In energy space, we have been working in AI and IoT based solutions since quite some time, and would take this opportunity to share with the audience and also learn from the August audience, August panel members here on what more can be done. So to tackle the digitalization and the penetration of renewable, we have a product called Grid Connect with the core aim of driving digital decisions across generation, transmission, and distribution. And as we go along, we'll talk more on the product itself, how it enables those use cases. But one of the very interesting aspects around how renewables have driven digitalization and AI, I would like to emphasize upon one large-scale project that was supported by MNRE and Ministry of Power at a national scale, with the core objective of integrating all of renewables into a single technology platform. So before we jump into integration, we need to understand how renewables are connected to the grid. And if you look at the left-hand side of the panel, 90% of renewables are connected with the state, and only 10% of them are connected directly with the central grid. Keeping this in mind, the concept was created called a dedicated renewable energy management centers, having three distinct requirements. One is that state-of-the-art SCADA. We provide AI stack to all those utilities, having larger penetration of renewables, provide interfacing with external services, be it weather forecast or RE forecast, and also automate the entire RE dispatch via central platform. And this is the project all about. The project was inaugurated by Honorable Minister of Power just about a couple of quarters ago in March. The core value proposition here, if you see, is that sitting at NLDC, now the POSOCO, the Central Transmission System Operator, can practically look at how each and every renewable asset is performing, not only with reference to the production data, also like the forecast values, asset uptime, downtime, curtailment information. The entire stack took like about 6 to 9 months to build, and now we are seeing the result of the overall integration. And as the time progresses further, while we have a massively ambitious target around adding more renewables, we'll see applications like this going to gain more and more ground. On the IoT space, we have again used sensors to interface with wind and solar farms, totaling about 11,000 megawatt of capacity, with the core objective of getting quality real-time data, because the grid integration of renewables call for real-time market operations. And for that, if you don't have a data, you can't make your forecast better. And that is what we enabled using IoT. As we go further, I have a small video I would like to share with the audience, which will take about 3 to 4 minutes.
Ladies and predictive maintenance across various demand-side management and response. This is where Grid Connect plays an important role. Unlike most other technology platforms, Grid Connect is an integrated platform which enables digital transformation for generation, transmission, and distribution assets. Grid Connect is a melting pot of technologies like artificial intelligence, IoT, automation, geospatial information system, and weather forecasting. Grid Connect empowers state-of-the-art predictive analytics for weather, electric demand and supply, IoT-based telemetry, extreme weather analytics for all asset classes, and wide range of workflow automation capabilities, unlocking operational and financial efficiencies for its users. The artificial intelligence stack of Grid Connect enables the user to monitor the performance of its geographically diverse assets in real time. The performance can be monitored at an individual asset level, various aggregate levels, regional level, and national level. The performance of each asset can also be evaluated in terms of prediction accuracies, revenue generation, imbalance costs, and performance benchmarking across various assets within the user's portfolio. The platform enables the user to track and manage the operational logs, downtime activities, dispatch instructions, and configure various event-specific alarms which may impact real-time grid dispatch. If the user is a large asset owner or a utility and prefers to have on-premise application for AI and dispatch automation, Grid Connect enables that as well. Grid Connect enables onboarding multiple external services like renewable production forecasting, demand forecasting, weather forecasting, and automate dynamic optimization of input forecasts to derive best possible final forecasts. The dispatch automation enables configuration of grid dispatch rules so that optimized forecasts can be further processed for real-time grid dispatch and market operations. Grid Connect has been deployed across 11 TSOs, including the national TSO, enabling grid integration and dispatch automation of 60,000 megawatts of wind and solar assets in India. For transmission and distribution assets, the AI stack can be further combined with GIS stack to monitor assets like transmission network or smart meters connected within the distribution network and monitor each asset at multiple aggregation points within the network. Each network point can be further modeled based on actual physical connections to identify and reflect upon any system contingencies, including any extreme weather events. Grid Connect can further enable a full-fledged smart meter analytics application which can enable many functions like data integrity checks, general demand pattern analysis and weather sensitivity, machine learning-based consumer clustering, cluster membership changes among consumers through different seasons and events, smart meter data anomaly detection, and peak load management tool which can be used by the host utility to achieve targeted peak load shaving through battery-based storage systems. For real-time market operations, high-quality data becomes essential. Unreliable SCADA can cause inefficient real-time decisions leading to financial losses. Our IoT stack solves this problem through remote telemetry. Our IoT telemetry sensors have been deployed across 11,000 megawatts of renewable assets in India and currently under trial for household-level telemetry. Our weather forecasting technology is being used by renewable asset owners, transmission companies, and some of the oil and gas companies to manage their assets against extreme weather events. The technology is also being offered to quantify extreme weather events to enable asset owners manage their insurance claims that may arise due to any extreme weather casualties. Grid Connect is being developed by a highly qualified and experienced team, and the technology platform has been conferred with multiple awards domestically and internationally. If you are an asset owner, having your assets connected to the electrical grid, Grid Connect can help you extract operational and financial efficiencies for your asset. Thank you.
Yeah, so that was the video about what a product can do. And for us, we are still like scratching the surface in this domain, and there is a long way to go for us in terms of developing the technology platform further. Couple of areas where AI and IoT alone can add significant value, both from the transmission and distribution point of view. Drawing upon from what Kunal said, there is still a massive opportunity for us as a country to apply IoT and AI-based solution. One area which stands out clearly is smart metering. Can we convert existing digital meters into smart meter using IoT and apply AI over it? We have 270 million smart meters and 99% of them are yet to be replaced. The question is, why replace? Why not, modify a structure slightly and make it work? It can save billions of dollars for India. The second aspect is transmission network. Can there be a solution, combined, a solution working with AI and IoT driven application where transmission?
Mr. Pandya, if you can just conclude, because we are running out of time for other panel members.
So yeah, the network monitoring is one area where IoT and AI can add value. And with that, I'd like to conclude the session. Thank you, everyone.
Okay, thank you, Mr. Pandya. I think when we talk about IoT in the energy domain, and also especially you can talk about any domain, whether AI, application of AI, ML. It's not a destination, it's a journey. I think we need to take it up, and we have to progressively bring in more applications, more data, and improve the system on a continuous basis. So very good example of how you have implemented your platform with some of these technologies. But going forward, I think this will be a really good ecosystem evolving in Indian grid to make it scalable. Yeah. So thank you so much, Mr. Pandya. So now we have Dr. Mohammad Rihan from AMU. So Dr. Rihan has been responsible for setting up 6.5 megawatts of grid-connected solar PV panels in the campus. So this is the largest setup in any educational institutes, in India. Complement to that, so Dr. Rihan has been working in this area. They also had something called Dean University, renewable integration into the grid, with the example what he has already shown that. And they also have 20% reduction in electricity consumption, energy reduction in energy consumption in the campus from the conventional sources. Very good achievement from there. So Dr. Rihan has been also the member of IET UK, and he has been the visiting scientist at the National Institute of Solar Energy, MNRE, since May 2019. So over to Dr. Rihan to share your views, your experience.
Thanks a lot, Mr. Rahman, and I would like to congratulate you for planning the session and conducting so well. And good afternoon to all my esteemed co-panelists also. It has been an enlightening experience listening to you all. And good afternoon to all the participants also. So as you have mentioned, we have experience of some project in the campus. So I'll try to focus on the what we have seen, what we have observed from that experience, because all the panelists have already underlined that this is absolutely essential. The Internet of Energy can be achieved only when we have this integration of power and internet and communication technologies. So as someone very rightly said, that it is going to be using megabytes to move megawatts. So I'll try to share my screen, and then I'll talk about what experience we have. So as you have mentioned, basically we are a university, so we are working in the area of smart grid and related concepts, the renewables and all. So we have been addressing the research questions also. Plus we have implemented 6.5 megawatt of solar PV, which is integrated with the campus grid, which includes a 3.3 megawatt solar farm also, and distributed plants on about 40 buildings in the campus. And we have been involved in the training of manpower also. We have already trained DISCOM engineers of UP State and the recent graduate engineers and entrepreneurs in this area. And I have been trying to contribute as a visiting scientist at the National Institute of Solar Energy related to the training as well as research questions which are there in this area. So this project we have, this is our solar farm, 3.3 megawatt solar farm, which is connected with the grid. And apart from this, we have 3.2 megawatt distributed on the different buildings in the campus. About 40 buildings are there. So based on this experience and plus what we have worked on different research projects and problems. So I'd like to highlight three aspects which I believe are absolutely essential to be addressed by AI digitalization techniques. Otherwise, it will be difficult for us to really succeed in this mission of decarbonizing our Indian electricity grid. So first, I believe is this transactive energy system. You see, for example, in our case, especially in Indian climate and especially in the northern part, we have a huge variation in the weather patterns. So in the campus, the daily consumption varies from 30,000 units in the months of November or so to about 65,000 units in May or June. So when we have this 6.5 megawatt capacity, it is sufficient for that 30,000 consumption. But when we talk about the May and June scenario, then it falls only about 10 to 15% only of the total consumption. Now, the policy which we have in the country right now, the net metering is applicable only to agriculture and residential consumers. So you cannot export this electricity to the grid. So how to best utilize this system? The same thing will come when we have a large number of residential buildings having this solar power. So this transactive energy system is going to play, I believe it is an important concept for the successful implementation of these systems. And as we all know, blockchain has been explored for this system. So this, I believe, is an important area which we should explore, which we are doing in the campus also. The second thing which I believe is this, you see, when we are talking of only a campus and there is such a huge variation, when we take up this on a large scale, so how the grid balancing has to be done, because the consumption is varying as well as generation is varying. So that comes to the requirement of forecasting. So we need to utilize these technologies for forecasting. Better forecasting is a must to achieve successful integration of these sources. The third point, I have mentioned transactive energy forecasting. Third point which I have observed is the related to the data. You see, this PMU has come up in a big way, phasor measurement units, and they are changing the transmission system. They are also supposed to come to the distribution side also, but the faster sampling rate means you are getting a large amount of data. And we have also tried to observe their impact on the grid integration point of 3.3 megawatt solar farm. So the large amount of data coming, to make sense of that data, we need to employ these big data analytics techniques. Similarly, smart meters, we are talking of smart meters when we are increasing their numbers, the sampling time again there is much small as compared to the conventional metering systems. And of course, the whole smart grid concept is based on other sensors also. So we need to utilize these big data analytics techniques. And this one more point I would like to highlight is that, for example, we have this 40 plants now in the campus. So we are one organization. When these plants are distributed throughout the city, then their maintenance, their management, their control. So in that case, this IoT based monitoring and control, I believe, is going to play a very important role. So these are the things which I believe are absolutely essential to have meaningful, successful implementation of this system. And one thing which Mr. Rahman has mentioned in that we need to highlight our how we are developing next generation workforce. So of course, university has to develop the workforce through their courses which we have in terms of BTech, MTech, and PhD. So we are trying to address these research questions. One thing I would like to highlight is that the power grid is changing in a very fast way, and somehow the academics has not kept up that pace. So we need to integrate all these developments in our courses, and these short-term training programs can play an important role for till the time we have properly integrated these concepts in our courses. So we are trying to impart training through short-term training programs also. And plus, I believe an important challenge is the DISCOM engineers, because DISCOM engineers who are now working, they have, when they graduated, these concepts were not there. So we need to take them on board also, because they are the interface between customer and the utility. So for that, MNRE and NICE have also done a lot of initiatives they have taken, and we have also been contributing to that, trying to train the practicing engineers and the faculty also. So that is all I wanted to mention here. And
so thank you so much, Dr. Rehan, sort of connecting megabyte with megawatts. But more so, I think we normally say walk the talk. But here it is an example of walk the teach. So what you teach, you are really implementing that in your own campus. And I'm sure this is a very good innovation platform for your students, for your faculty, for your researchers to really take the data, real-time data from your campus system, the renewable energy system, to do their research, find problem statements, find opportunity statement to work on, and also maybe collaborate with the industry and other stakeholders on this. Really good example of that, and I congratulate you to having spearheaded this. So we are going to the next panelist now, Dr. B.K. Panigrahi. So professor in Department of Electrical Engineering, IIT Delhi. So Professor has been the head of Center for Automotive Research and Tribology, CART, IIT Delhi. And he also has experience in AI, ML tools and techniques in the power system area, operations, planning and control, protection, and also has worked in the issues of EV charging infrastructure and impact of fast energy infrastructure on the grid. Very important topic when we want to scale up the renewable energy in our grid. So Professor has been, author of several papers in IEEE, IIT, Elsevier. So Professor Panigrahi, over to you to share your views.
Thank you, Dr. Rahman. I hope I am audible.
Yes.
So it is really very difficult for me to speak for 5 minutes after all the eminent speakers has talked about the so many things. So with due respect to everybody, and with due respect to Mr. Bhanu Prasad Yadav and Dr. Rahman and all my fellow panelists and all the participants in this particular occasion. So I'll just talk because like Professor Rehan, I am also an educationist, and our main job is to create the manpower. But nowadays the focus has been changed a little bit. So we are creating the manpower for different sectors, as well as also we are trying to have set up in IIT Delhi a culture of startup, which the industries can come forward, the new brain can come forward to create this startup. So looking into this particular area, because all have been already spoken about, so my theme, what I generally work, and particularly if we need the AI and ML and IoT can come to our rescue in the case of the energy sector, then ultimately it leads to create a smart, sustainable, secure and self-healing grid. The most important thing why I'm talking of this, because as we are incorporating more and more renewable generation, each generation is having its own merit and demerit. I'm not going into that, particularly the solar, wind, the hydro, and biomass, etc. But if you look into the solar and wind generation, the major challenge is the variability and uncertainty. So if there are variability and uncertainty to handle this in a generation mix, particularly it creates a lot of problem to the deregulated power market. So to handle this variability and uncertainty, we require, as many of my speakers have already told, an efficient AI tool for forecasting of these renewables. Because if you can't forecast with a very narrow band, okay, instead of going a point forecast, we are doing some work where we are looking into the prediction interval and confidence interval to make a compromise solution between the prediction interval and confidence interval, so that you can predict as close as narrow band. Because regulatory commission comes up with the generation should be committed within a narrow band. If you violate that band, then you have to give the penalty. So there is a need of the AI tool and technique, particularly with larger integration of these renewable sources into the grid for planning, for operation, as well as the management. And also, these create a lot of challenge, particularly the protection of the grid. So we can't close our eyes for the protection or the blackout which may happen because of the if you are not managing the grid efficiently. So the question is now, not only the integration of these renewables, but also now we are coming up into the integration of more and more storage into the grid. Okay, so when you are coming to the storage, either it is a static storage or it is a dynamic storage. I mean the storage of the electric vehicle. We may have a large parking lot may come up in future where there are thousands of vehicles can be parked. They, as a whole, they can work as an aggregator. They can sell power to the grid, because once you are coming to this availability based tariff or time of day tariff, then ultimately you have to schedule all your resources. That means the generation vector, the storage vector, as well as we are talking of the prosumer. I myself is a prosumer, so we are talking of a lot of smart homes together which can work as a prosumer. So ultimately all these things can be managed in a better way. So forecasting and the management is also a challenge into this. This is just recently 3 days before this has appeared in IEEE Spectrum in 23rd November. The creation of the autonomous grid. So they call this creation of the autonomous grid is the meeting point of AI, renewable energy, and energy storage with an ultimate aim to optimize the grid. So this is the example of Colorado neighborhood of Basel Vista. They have created a microgrid. Already Dr. Venkataraman has talked about this microgrid. So ultimately we want a self-sustainable microgrid, which may be an off-grid, which may not be integrated into the grid. And this microgrid must consist of all electric home. So this is the new concept with all communication technology, IOT, 5G technology. We can create all this, and this is the need of the hour. So this is just the verge of IOT and AI. Only AI cannot do anything. AI is the tool and technique, but these tools and techniques are to be applied to certain application domain. So I must tell to all the researchers or startup companies, etc. First, we have to understand the need in the electricity domain. Then we can devise the IoT and AI infrastructure. Because devising any algorithm or any devices, but we have to look into the application. So that is the major challenge. We can have energy management, demand response, smart building, reserve allocation, ancillary service, smart mobility. So these are the very different area. I'm not going into the detail because the time is very less. So just these are the focus. All of my speakers have talked about this. So there must be a congregation or segregation of the IoT and AI tools and techniques. So basically, Dr. Tripathi has also told about the smart grid is a combination of operation layer and the IT layer. So it is OT and IT. So that's why we have to look into various cyber security aspects in that grid. Dr. Rihan has talked about the PMU. So we have installed in the power grid many PMU. So this PMU data should be utilized even for disaster management. We can predict this natural disaster which are coming, looking into this PMU data. Can it happen? Definitely yes. So cyber security, situational awareness, automation, these are the one of the important aspect where the AI and ML tool can play a very important role. most importantly, to teach all these areas, we have to create the digital twins for the energy sector. Ultimately, this digital twin enhance the efficiency and they boost the productivity. So we have to create the digital twin, the knowledge about the grid, storage, vehicle. So this may be model-based approach or data-driven approach. We can do all this. And finally, the tools and techniques which are used are, neural network, fuzzy logic, natural computing. But my important point is, lot of tools are available. Lot of techniques are available. Lot of source codes are available for the students. But ultimately, you have to choose which is the best tool, best technique, best software, and not only the software. For the large amount of the big data analysis, you require also an equal amount of the hardware. Okay, so there must be a compromise solution between the software requirement to implement the AI/ML tools and the hardware requirement like fog computing, cloud server, etc. So that is what I want just to convey in detail. So thank to all of you. We can have a discussion later on. Thank you, sir.
Okay, thank you so much, Dr. Panigrai. I think it was the best way to actually summarize what the different panelists have been talking about. We have been discussing, sharing our experience. And so many times people say that, okay, are we sort of trying to just for the sake of using the technology, the digital technology? I think somebody has to mute, okay, getting a lot of disturbances. Okay. So when people say that, okay, for the sake of probably using the technology because they are available, the IOT, the Internet of Energy, the AI, ML, we are using it for the sake of it. But I think Professor Panigrahi gave a very good context there. It's all about when we are increasing the renewable energy in the grid, and we are seeing more and more variability, more and more uncertainty. And somebody may say, okay, we have human intelligence. Why do we use artificial intelligence? I think when we talk about this variability, uncertainty in the time scale of millisecond, it's humanly not possible to really, even if you put thousands of scientists together to analyze a problem, it will take time. There is no time left for the response. I think there actually this AI, the artificial intelligence, the machine learning system would help to collect the data, as Dr. Rihan talked about, the megabytes and connecting megabytes with megawatts. This system takes the data in real time, analyzes, and then discovers some problems or maybe opportunity to solve. And also, as I talked about, that this data is then available to the larger set of stakeholders across the value chain who can work together on the same problem to solve it, and also make it operational in the system in future, having a machine learning, the deep learning system there. So it's not about just for the sake of applying technology. I think we have seen the examples of panelists sharing that how they have been using it in the entire value chain of the renewable energy, starting from manufacturing of the cell, the panel, the system, the integration, the microgrid, and also connecting with the grid, doing the forecasting of the energy, renewable energy, and also the operation, and including adapting new type of loads in the system. For example, EV charger, fast EV charger, like as ABB, we also have ultra fast EV charger. Let's say it's like 8 minutes, you can charge your car for 200 kilometers. There is flash charger where the bus can be charged for 20 seconds when it is stopping near the bus stop or top of charging. So you can imagine all these loads, if they are on the grid and they draw a huge amount of load, the current impulsively, and how do you make the grid sustainable? At the same time, you have more renewable energy available in the grid. So I'm very glad to have all the views from different panelists in their subject matter of expertise. Now we will have a couple of questions. I've seen the questions. Maybe I'll just try to formulate, just relate some of the questions and then see how we can address them. Just give me a Okay, so let me start with one question, Dr. Venkat. So you talked about microgrid and how the fuel cell technology is integrated with the microgrid and how especially it can be effectively used in disaster kind of situation, whether it's a fire situation or hurricane, cyclone. I think as Bloom Energy, you have done that, and as you know, in our country, we have sometimes a situation like this. So how it can be effectively used in this, and what kind of sort of ecosystem you would like to have in the country to really make it operational. Of course, microgrid as a subject, as a technology we are all familiar with, but how it can be used for this kind of situation. People may not have seen that example. I would like to have your views and sharing what exactly you have done in that area.
Yeah, the main thing people have talked about the electrical systems as well as the part of the data side of it. In the microgrid environment, the way we have dealt with this is obviously we got different sources that can coexist. Number one, in the microgrid. Second one, you also have to have a way of disconnecting completely away from the grid and be able to be an islanded solution. Right? Those are the main top level things you can do. So in theory, I think the way we have done it is even taking some of the people who are the electrical engineering can think about the droop controls that we can do, whether you are going into a voltage source or current source. All these algorithms have been developed fairly well, by Bloom being the primary source. And the supplemental sources have been with you can have storage, you can have solar, whatever the source you have. And you have the capability of running it, supporting the load as load following that exists today. Even Apple campus today has got the microgrid where Bloom is the primary source. We are integrating with the solar and batteries. So the technology as such exists. The challenge for India would be that if you make, I'm thinking of just Bloom being the primary source, how do you actually bring it to both the urban settings as well as the rural settings? The way we are thinking about is the urban settings, we can use the natural gas for us as well as the biogas for the rural settings. We have demonstrated the biogas piece of it. That's one methodology we can use, where if you have the fundamental source of power, or which is going to be a constant power, and you bring in the solar panels, or you can have an on-site storage, those can be done fairly well. Future, I think we are thinking about hydrogen as a storage vehicle. That is it's still evolving, but that may be another opportunity India can think about. The main thing is that we need a policy help from the government also to make these microgrids work, because it's not necessarily tuned for just for natural disasters. It can be done for anything, even for the local community. We can do it fairly easily.
Okay. Thank you, Dr. Venkat. A very important point that how we can make it happen, whether it's a microgrid in different application area, disaster management, or remote areas of the country where the grid power is available, but not 24/7. Of course, that is what we are striving for. Definitely, we'll reach that. Remote desert area or maybe hilly area. So there, how we can use effectively the microgrid. So coming to the policy in this direction, I think we have a very good sort of, I would say, encouragement from the MNRE. Mr. Bhanu Pratap Sinha is already there in this call. Yadav, sorry, Mr. Yadav is there. So if we come up with a good example by having a collaboration, I think this is something the government supports in terms of then it becomes a best practice. It can be shared. It can be a guideline for others. Many times you put up a standard, but it's very difficult to implement. But something which is a concrete example, then that becomes a problem. And Mr. Yadav can definitely agree to that. This is how the government has been encouraging and supporting and also bringing all the different stakeholders like us to share our knowledge, share our experience, and then come up with some real pilots. So definitely we can look at that, how we can collaborate together. I would like to have some questions like, okay, Mr. Upadhyay, you have heard about different technologies, different concepts, right from the research to also product development and also innovation. How do you see this getting realized? Because ultimately, it's not just the technology; it also should be supported by some business model. So, how in the country we have the environment of really, supporting this from the government, from the policy, from the venture capitalists, from the the industry to scale it up? I'm sure there are a lot of examples, but how do you see that happening?
No, good question, Mr. Rahman. Clearly, the government, the academia, the private sector all have a very important role to play in making this change happen. Of course, as we all know, entrepreneurs are the real disruptors. They are the ones who try converting the ideas into actual enterprises, which go on to create a massive impact. They require significant amount of capital. In my mind, capital is the biggest missing piece in the Indian context. We need to make that capital available for the entrepreneurs, whether it is for testing, whether it is for piloting, whether it is for scaling up. I think the government has to play an active role in creating pools of capital. And there's been a lot of research done on this globally in the past, that this is not a sector wherein the regular venture capitalists would want to come in and invest in, because the risk reward profiles are not just right from a VC standpoint. And therefore, it's really strategic capital and developmental capital that will have to be brought to play here. At the same time, I think while I am emphasizing the role of capital, what is equally important is, given the fact that this is a sector which is not necessarily under easy control of an entrepreneur. I mean, there's utilities involved, there's government involved, there are massive large companies involved. I think all the stakeholders would have to become more accepting of the changes. You have to be willing to take the risk. If you don't take the risk, I mean, there's a good chance that the entrepreneur will still come and disrupt you. So it's best for you to join hands and go about co-creating these solutions and creating the impact.
Okay, thank you, Mr. Upadhyay. I think the co-creation is the right approach. Okay. Mr. Upadhyay, I think the co-creation, what you talked about, is the approach. Probably we can deploy something quickly and also scale it up. Co-creating, it is not that we develop our own and then we start looking for where I deploy. I think right from the innovation, the research phase, we need to work together, create something. Also, bring in the prosumers, the consumers, people who are going to use this system and also consume the energy. They also should be in the place, in the ecosystem to really do it. Then it will be faster. Here I will just take from here to Dr. Abhishek Kumar. I mean, you talked about how you have reduced the development life cycle from 10 years to maybe 2 to 3 years or 4 years. So definitely that's a very good approach, which is the need for our country. We have a lot of technologies. We have experts. We have incentives, promotions, and also the motivation available from the government policymakers. So, but how do we make it happen? Squeeze the time and then deploy it faster. So, any you can share any, because you start from the research side and you have seen how it has been deployed. Yeah.
Sure. Thank you very much. I think one of the main aspects for quick development is, for example, a lot of test bedding activities, because one of the important factors is that when there is a new one, it's important to do kind of test bedding, quick deployment along with companies, academics, as well as research institute. And this basically helps in the de-risking of the technology for wider scale application. I can give an example here. This is not for in case of digitalization and AI based. For example, in solar industry, why different sectors, for example, floating PV as well as building integrated PV has not been moving fast, because obviously as a big developer, one would foresee it as a risk and would not like to pour in a lot of money. To have a faster deployment, a consortium formation in terms of industry led by industry most priority, because it is more relevant when it is led by industry, but is supported by academics as well as industrial research to bring it from lab to fab scale. Those type of initiatives would be very helpful. We have seen something similar in Singapore as well, where basically a lot of consortiums led by industry, supported by industrial institute, and also supported by the implementing agencies has brought these faster transformation from lab to fab scale.
Okay, thank you, Dr. Kumar. So I have now sort of message from the host that we need to wrap up because we are already over time. So many of the questions, they were answered because we also discussed that. I think I'm sure audience, they would they have many of their questions, they have been answered, and this I can see also questions here which are already covered in the presentation by our panelists. So just to sum up, we have seen how from the academic research to industrial research to develop a solution for Internet of Energy using AI, artificial intelligence, machine learning, data analytics, and it has been implemented not only in the operation but also in the manufacturing of the components, analyzing the system, forecasting. We have seen the entire value chain, how this has been used. It's not about AI and Internet of Energy is a subject of computer science or computer engineering. It's all about a tool, a technology which can be used in any domain. We are talking about here, starting from the cell and panel research where, it's more material technology, but this has been used there effectively. And basically, when we talk about AI, artificial intelligence, I think it's all about how we can make it more predictable, whether it is operation, whether it is any issue during the operation of the grid, operation of the microgrid with the solar energy, with the renewable energy, how to make it more predictable and also quickly in millisecond, in second, in minutes, and at the same time the system is evolving where a lot of changes are there. So having this AI and machine learning platform would really help to discover problems, to discover opportunities to improve, and also make the entire system, the data available to the largest set of experts, including you. We have a lot of different stakeholders here. I think the need is that we come together in different way, some or other way, to really work on some of the pilots, work together, co-create, deploy it, and demonstrate. I think we have, as I said, great support available from the policymakers, from the government to really scale it up and also scale it up very, very fast. And we have seen some examples here. So with this, I would like to conclude here. Thank you so much, MNRE. Thank you, Mr. Yadav. He's actually the force behind this, and also the idea, the brainchild of this session, and also the topic, how we should deliberate. Thank you, Mr. Yadav, so much, and also your team for organizing this. And we have, of course, the contacts of the speakers available, so the audience, they can also get in touch with the speakers, the panelists later. And looking forward to some or other way connecting together, and also your connections, your teams, how we can build the solar ecosystem, the renewable energy ecosystem in the country, and make it faster, scalable. So thank you so much. So I think, so Ms. Shreya, any last word from you? From
no, sir. I think thank you. I think Mr. Yadav dropped out. He has another session started.
Okay.
So thank you, everybody.
Yeah. Thank you very much.
Thank you everyone.
Thank you.
So, namaste.
Nice interacting with you. Thank you.